Okay, let's get going here. This is it's 5/8 today, and this is video number 68, and we're going to continue and elaborate on the ideas of adding and subtracting. As I tried to tell you, this is basically a 7th grade topic, and we're working directly off the Regents book. However, we want to make sure that we can work on everything that we can do here. And today I'll also, this morning, give you a little lecture on a very, very important idea in high school math called restrictions. So let's get started here. Got all these papers all over here. There we go. And we're focused more on the idea of subtraction. I'll explain that in a second. And this is number 38 from your Regents book. We're using these problems, and I'm using their numbers, so for reference purposes, their problems are just as good as anything I could come up with. Okay, so here's problem number 38, and they say find the difference when x squared plus 8 minus 2x is subtracted from, and then you have another algebraic expression, that is a polynomial. So when we look at this, we have to find the answer and check it, and we're going to see that, you know, what's really going on is these algebraic expressions are just becoming sort of numbers in our minds. They're replacing the number system with x that we learned before, and instead we got all these different powers. And for example here, when I look at the first one here in 38, notice that they didn't put it in standard form. It's a trinomial, third degree, right? That's what third degree means. And it's not third degree, I mean it's second degree. It's a trinomial with 3 separate terms, okay? And when we look at the second one there, we see that this is also a, has 3 terms, right? Okay, but its degree is 2, so this is a quadratic and this is a quadratic, okay? So we come up with a word that we're going to use a lot, a quadratic trinomial. And so that's what these two guys are, that's their name, and we're asked to subtract one for the other. So as I always teach it for the weaker students, especially with the weaker students in mind, someone says find the difference of, when 5 is subtracted from 8. And we see that the kid who speaks decent English, or the kid who's thinking about what they're saying, 5 subtracted from 8 means what? 8 minus 5. So they want you to read through that, and there it is. You can click it, you can stop it, but there's no difference between the first example, number 38, from the Regents book, and the elementary school problem when I said find when 5 is subtracted from 8, and they're both going to turn out to be the same thing. So let me do the math then. What's subtracted from what? This is subtracted from this. If you don't believe me, just look at the picture that I just made. So here, I put it in standard form. That's another reason why we'll do these as exercises. And there we go again. We repeat that. There's x to the 0 here, x to the 1. They want you to understand that at your age. And this is subtracted from that. And now maybe this is the first time, I doubt it, I'm subtracting the whole thing placed in standard form from what I was subtracting from. And I'm going to pause there so you can see that, so the weaker students can see that. But that's subtraction in polynomial math. Again, quadratic trinomial, we're taking away another quadratic trinomial, and subtraction only means that the expression itself, whatever positive becomes negative, and whatever negative is becomes positive. And you need to understand that. And that's the essence of subtraction in high school math. Let me move this over just a little bit over here. And there you see that what I've done, and again, I'll continue the problem left to right. And now notice I put everything into standard form. And so when I rewrite it, whoops, I rewrite the whole thing. I got minus 10 x squared plus 2x. Some kids might not want to do it this way. I'm going to do it this way because it's the first time. You can do this vertically as well as horizontally, which I'm doing now. You'll have to decide what suits you better. Let me move this over a little bit. And you see I just took the opposite of whatever was in the parentheses, which was what I was subtracting from. And that's it. That's the idea. Now I put together my like terms. Again, I hope I'm not in your way, but I'm not doing anything that you don't already know how to do. There's the highest degree. There's your 4x. And there we go, positive 7, negative 8. And there's your algebraic expression, your quadratic trinomial, quadratic meaning degree 2. And does it equal anything? No. That will change down the road, but right now, we're just like we were in 7th grade. We're just putting things together. So I'm going to give you some problems like this. I'll assign them to you, and you'll do them. Okay? And we can reassign them if there's any problems here. So I'm going to erase all this now. And I'm going to change the topic just for a little bit. It's really something that we needed to get on as freshmen, as high school students here. Let me just get all this off the board. Sorry to waste your time there, but there we go, just to make it a little better so we can talk about a really important topic of freshman high school math. How could something be more important than restriction? So I'm going to talk for a couple seconds, and I hope you're listening carefully, and I'm going to focus the tripod over here a little bit, and we look at this. So in the last lesson I said, what's the perimeter? So we took the 4 sides up. Sometimes you can label the vertices and all that, but the answer seems to be so boring. And I know I get a lot of questions over the years from some of the kids who are thinking about this stuff critically, and they say, what are you talking about? What does B mean? So I might say, well, B is a variable, it's any number we want, but that's false. If you think about it, B can't be any number we want. Look at this picture here. This is some sort of polygon. I mentioned that last time. I mentioned it, polygon. It means many angles. The angles are different. It's just an arbitrary quadrilateral in space, 2-dimensional space on the plane, to use all the words that we like to use. So that introduces the idea that we really need to talk about just for a couple seconds, and then I'll calculate the perimeter, and then I'm going to give you a brand new word over here. I'm going to write it over here. I think you'll like the word. A lot of you will like the word. It's called a solution set. And this comes up naturally when we do math. Okay? So let's take a look at this. We say that we have some sort of polygon in space here, and these are the algebraic expressions we assign to it. And the math teacher says, well, B is any number you want. It's a variable. That's false. What if B is 6? Let B equal 6. All right, so this is 15. This is 11. This is 3. What's this? 0. Sorry, my friends. If this is a polygon, B equals 6 is an incorrect answer. There's no such polygon where B equals 6. Aha. That's the idea of restriction. Get it right away? Whatever B is, B has to be less than 6. Does everybody see that? I don't want to get into inequalities now. I'd like to do that eventually, but time reasons as well. But if you just look at this right here, if b is 6, this side is 0. If b is 7, this side is -1. Anybody want a polygon with side -1? We call that a restriction. A restriction is when there's certain b's that you can't use. Well, let's take a look at this side over here. What if b is 3? Well, if b is 3, this side is what? 0. So b has to be greater than 3. Does everybody agree with that? Look at it. Just look at the math here. So before I do any kind of perimeter, I'd have to look at the restrictions. This is what the math problem given to me allows me to say. So if b is less than 6, and at the same time b is greater than 3, and we just say we're going to use whole numbers here, or positive numbers, then the solution set, notice the bracket, is 4 and 5. Those are the only numbers that work if we accept whole numbers, right? Every other number fails. And this is called a restriction. And this is called the solution set. Right here, we're restricting what we can do. Otherwise, it's not a polygon. Here are the two numbers in the universe when they're whole numbers that work. Notice these are not parentheses. These are brackets. If you're paying attention, keep in mind what I'm saying. I'm showing you the future. Okay? So that answers something that might come up with especially some of the brighter kids who think about what they're doing. So now if I go back and I say, what's the perimeter here? Well, I'll just start at the top and go clockwise. There's 2b plus 3. There's 3b minus 1. And there's b minus 3. And I got to put this backwards, remember guys? Plus 6. And now I get a more boring answer since these guys cancel. I get 5b, and these guys cancel, plus 5, apparently. Okay? So that means there are only two possible perimeters. 5 times 4 plus 5, and 5 times 5 plus 5. So the only two possible perimeters are 25 and 30, if these are the algebraic expressions that we had chosen. Very important to think about what I just taught you. Now later I'm going to do some of the assignments that I gave you yesterday. I know kids want that to be very important. I want you to think about what I just did here when I talked about restrictions. And this particular problem here, when I found the perimeter, it was subject to the restrictions and a specific solution set. So there you go, as the administrators in our school want us to do, a little bit of mathematical enrichment. Okay,